morning. We're going to do an introduction to congruence today, and hopefully you have some familiarity with congruence from year 8. But basically that tricky sounding word congruence just means that two figures are identical. They are exactly the same shape and size. They could be in different orientations. They may not look congruent at first, but if we move them by flipping them, rotating them, reflecting them, and we could place them on top of one another, we would find that all the sides and the angles match exactly. And we want to just make sure we remember how to use a symbol for congruence, and that is a very equal sign. So an equal sign with an extra line in it that just gives us the idea that they're exactly the same or identical. Okay. Now we want to look at how we prove two triangles are congruent, and that's what we spend a lot of our time doing, proving triangles are congruent. We could prove all three angles and all three sides match in both triangles, but that sounds like a lot of work. So what we've done is develop tests based on the smallest amount of information we need to prove two triangles are congruent. You don't really need to write that down. That's just explaining what we're going to look at on the next slide. So if I asked you, if I have two equal sides in a triangle, can I be confident that those triangles will be exactly the same? And you can see here that I can't be confident of that. So if I choose a triangle with sides of 6 and 8, I could actually have a big angle here, which would give me a long third side. Or I could have a small angle here between them, and it would give me a short third side. So saying two triangles have two equal sides is not enough to tell me that they are exactly the same. What about here? If I have three equal angles, does that tell me that the two triangles will be exactly the same if they have three equal angles? And I can see here my angles are exactly the same, but my sides here are quite short, whereas my sides here are quite long. So neither of these situations would work in terms of proving two triangles are congruent. So what's happened is we've developed 4 tests that do work, and if I can show, actually I will go back, if I can show here that the 3 sides are equal, then obviously the angles will be equal as well. So I couldn't have this one long side and one short side. Or another way of thinking about it is, if I have 2 sides given to me, but I stipulate what this angle will be, it will also mean that I will have 2 triangles exactly the same. So these 4 tests have been developed. I'm going to get you to write them down. Very important that you know these tests and you know what they're called. We have these abbreviations for them. So SSS is just standing for side, 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 angle, side, angle, angle, side, and right angle, hypotenuse, and side. And what they're saying is, if 2 triangles pass one of these tests, they are congruent. So if each triangle has 3 corresponding sides that are equal, then the triangles are congruent. If they have 2 corresponding sides and the angle between the sides, and that's very important, it's the angle between the sides, are equal, then they're congruent. If they have 2 corresponding angles and a side equal, they are congruent. And if they're both right-angled triangles, only in right-angled triangles this one holds, the hypotenuse and another pair of sides are equal, they are also congruent. That might not sound like it makes much sense, so let's do a practice proof. First of all, we just need to make sure we can match sides and angles in congruent triangles. So we can see here, I have 2 triangles with exactly the same side. So I have a 5 and a 5, a 6 and a 6, and an 8 and an 8, but they're in different orientations. So I just need to make sure, first of all, that I can match up these sides and angles. And this becomes quite an important part of congruence, making sure I can label things properly. So side AB in this triangle is exactly the same as side FE. AB matches FE, or corresponds is another word we like to use. BC matches ED, and AC in this triangle matches FD in this triangle. So there's matching sides. Now we want to match angles, remembering how we label an angle. So if I want to talk about angle, this angle here, I must start with the furthest arm, or one of the furthest arms, A, go to the vertex B, and then out to the other arm. So I must always have the vertex in the centre of the label. So I want to know what angle in the second triangle is the same as angle ABC, and what I'm looking at is this angle is between 5 and 8. So this angle matches angle ABC because it's between 5 and 8, and so I would say angle ABC matches angle FED. Then angle BCA in this triangle is between 8 and 6, so I'm looking for the angle between 8 and 6 here, and so I'm going to say it matches angle EDF. And finally angle CAB, which is between 5 and 6, is matching to angle EFD. And we're going to use them now to do a proof. Okay, here I have two triangles. They're connected here at this point C, and we want to prove that triangle ABC is congruent to triangle EDC. We're always going to follow this same pattern. We're going to say in triangles ABC and EDC, and what we're going to do is prove 3 points. 3 things that we know are equal according to one of our rules. It's sort of a bit like doing a puzzle, so we need to look at what do we know. So obviously I can see on the diagram I've been given that AC is the same as EC. They're equal, so that's one bit of equal information. What else can I see? Parallel lines, that tells me there's co-interior, corresponding or alternate angles somewhere, and in this kind of format we can see pretty easily there's a Z shape, so I've got alternate angles, and also I have vertically opposite here. I've got to write them down, doesn't matter what order I do them in, but I am going to have to label carefully. So first of all I want to say AC equals EC, and I always give a reason, and I'm going to say that's given to me because I'm told that information. Number 2, angle BAC. So this angle up here, angle BAC, is equal to angle DEC. I've got to give a reason. My reason would be alternate angles. And I might also want to say AB is parallel to DE. And then my third bit of information is angle ACB. So looking at these ones here, angle ACB is equal to angle ECD. And why is that? Because they're vertically opposite angles. There's my 3 bits of information. I need to double check what sort of information have I got. I have a side, I have an angle, and I have an angle. And if I go back to my tests somewhere, oops, there we are, sorry about that. I've got an angle and a side. So that's how I work out which test I'm using. So now I say, therefore, triangle ABC is congruent to triangle EDC, and I always finish with, I've used this test, AAS. Now what I'm going to do is always do the same format. In the 2 triangles, I'm going to say then the 3 bits of information I'm proving, every one of them with a reason, and then my final congruent statement. Therefore, I've proven they're equivalent or congruent, and I've used this test. Let's try another example. So here I'm told triangle ABC is isosceles. That means these sides are equal. It also means these angles are equal. So there's lots of information on this diagram to help me. I'm going to start with my first statement in triangles ABD and ACD. So I'm looking at this triangle and this triangle. What are my 3 bits of information? I'm going to use these sides being equal. I can also see that I have 2 right angles here, and we'll have a look at our third bit of information. So number 1, I'm going to say AB equals AC, being careful to label them as matching sides. And what's my reason? Isosceles triangles. Number 2, I'm going to say angle ADB is equal to angle ADC. So angle ADB is equal to angle ADC. That's given, and it's 90 degrees. And the third bit of information sounds a little bit strange at first perhaps, but if I look at this side AD, I can see that that's part of this triangle here, but it's also part of this triangle here. So what I'm actually going to say is AD is equal to AD, and I'm going to use the word common, meaning that side is in both triangles. It's common to both. And finally, what do I do last? Say therefore triangle ABD is congruent to triangle ACD. And what reason am I using? I've actually got a right angle. I've said there's a right angle that's the same, there's the hypotenuse, and there's another side. So it's actually the RHS test. Let's do one more. And here I have two triangles again connected, looking for the bits of information that I want to use. This is an easy one. I've been told these two sides are equal. I've been told these two sides are equal. And my third bit of information is going to be that these angles here are equal. Hopefully you can work out why. So have a go at this one. Try to set it up and then have a look at the solution I'm putting up. So first of all, it would say prove triangle ABC is congruent to triangle ECD. So first of all, I'm going to say in triangles. First bit of information, BC equals DC, given. Number 2, AC equals EC, also given. It's a perfectly fine reason to give. And 3 is angle ACB is equal to angle ECD, and the reason is vertically opposite angles. And I finish off with therefore triangle ABC is congruent to triangle ACD. And what test have I used? I've used side, angle, side, making sure that always when I'm proving this test that the two sides I'm showing are equal here. I also am including this middle angle, we call it the included angle, between the two sides. That's important, that I'm finding that, I'm proving that angle is the same as well, the one in between the two sides. Okay, hope that makes lots of sense. Enjoy some practice that your teacher will set. Thanks, bye.